can find it under assignments or on the weekly calendar. Today's date is January 6th. I would be remiss if not to mention what's going on in the news right now down in Washington, D.C. So just know that I think the school is planning to have a little forum for discussion. If anyone's interested in that later this evening, I think they'll have an email out about that. I'm happy to chat about anything with anyone, either if you've got opinions to express or anything like that. We're all here for you, and yeah, just kind of keep yourself updated. It's the biggest thing you can do. So I'm going to welcome the distraction of learning about a little science, I think. And we'll start off with our usual pair share breakout room. This is kind of a simpler question. Today in the chat, the question is, what is your favorite TV show? However, I know not everybody really watches TV now, so you can think of it as like, what is your favorite streaming show? So this can include shows that are on Netflix, Hulu, HBO, Disney Plus, Peacock, Amazon Prime. It just has to have multiple episodes, so it can't just be a standalone movie thing. We'll have a movie question later on. So think about what's your favorite TV show, and what's something that you watch a lot, or find yourself quoting a lot, or find yourself thinking about a lot. That's how I think of like favorites, or something that means something to you. So think about that for 20 seconds. And don't forget to say hi and check in and chat with the person you're in a room with. We'll come back together in 2 minutes. Rooms are open. On the homework, anything you found challenging? Alrighty. Okay, then the first thing we're going to do today is I'm going to have you touch back on your carbon footprint data that we took back in September. If you guys remember that long survey that you completed. So on the tasks to complete list, this is now step number 3. There's a link there to an assignment. It's a big quiz. It'll look like this. And so if you remember, you completed that big survey online, and it gave you this weird table where it calculated your carbon dioxide emission contribution in kilograms of carbon dioxide. And then it also compared you to the average for your region, which you should have entered. I'm going to focus mostly just on comparing your guys and your data. And so what you're going to need to do in the first question is open up the class data. I've made a kind of cleaned up version. Here's what it'll look like. And so you just need to find your name, and your number should be right there. And then you're going to use those numbers to answer the first few questions. So I calculated the average for the class for all 3 of my sections. And so you can kind of compare your numbers to everyone's numbers for home, transport, food, and purchases. And then I have graphs of our overall data. So here's a graph of males versus females. Here's a graph of USA versus living outside the USA. And so just kind of to get your thoughts about some of the differences you see between those and what you think might be contributing to that. So I'm going to time for 15 minutes to work on this. I'll be here listening if you have questions. And then we'll come back together after 15 minutes, or once it looks like most of you have completed that quiz. So 15 minutes to work on the carbon footprint analysis. Let me know if you need help. All right. So hopefully it was interesting kind of seeing the average data. Also kind of the big takeaway overall though, hopefully if you noticed with the numbers, does anyone know what was the biggest area of contribution, like for everyone across the board? The biggest contribution of carbon dioxide was which category? Was it home, transport, purchases, or food? You remember? It's not surprising. Sophia?
Is it transportation?
Transportation, yes. So, and it's probably most likely because of carbon emissions from cars and airplanes and that kind of thing. Anyone know what the lowest one was, which I was kind of surprised by? Camille?
Purchases, right?
Yeah, which I'd be curious about that now, or if there's some way to adjust it, since everyone seems to be doing purchases online. And I feel like transport costs come into that. Like I feel like now so much of what we buy is driven to us rather than we go out and get it. I don't know how that's factored in during these surveys, but all right. So what I think is interesting though is looking at the class averages overall for the graphs. So being careful here. Did anyone have any explanations they wanted to share for males versus females? So first of all, what do you notice overall? Who has the larger carbon dioxide contribution, male or females? You just shout it out.
Male.
It is males. And they seem to have actually, which I think is kind of like, where do males seem to be the most different from females, in which category?
Home.
Yep, home's a big one. I would
Food.
also,
Oh wait, shoot, food.
yeah, I'd say food also looks like it's pretty different. So I guess boys are just cramming their faces with more, carbon taxing foods. I don't know if I'd say that boys eat more meat. I mean, I don't think that would be a general trend. I mean, maybe that could explain something, but I get the feeling it's probably more along the lines of junk food and stuff like that boys might have more preference for. Anyone else have any other ideas about what might be driving this difference? I can't remember any of the specific questions for home about where you'd see differences there. But anyway, well, I look forward to reading responses. This one was not surprising at all about USA averages versus outside USA averages. So obviously, what's the one category that made the biggest difference?
Transportation.
Yeah, that's not surprising because we were still taking their survey, I think, with the idea in mind of living at home, but also, being a boarding school. It's not surprising then that students who live outside of the USA have slightly higher transportation contributions because they're probably doing a lot more flying or driving from larger distances. And that, honestly, though, that seemed to be the one thing I should probably rearrange this to do a more direct comparison. But you can see that all other categories, home, food, purchases, all seem to be relatively similar. It seems to be transportation that's really driving that key thing. So again, electric cars, trying to fly less seem to be one of the big things you can try to do to reduce your carbon footprint. Any other questions or comments on that? All right. So we know carbon dioxide plays a big role, but let's now talk about what are some of the things that you could do to reduce your carbon footprint, right? We calculated this, how can we contribute less? And so one way to do that is, to explore this, is to read this article from CNN. It's like a little quiz that you'll take. And so again, it's on tasks to complete. We're now on step number 4, curbing climate change. Click on that link right there, most effective ways to curb climate change. It'll take you to a quiz that'll look like this. And you're just going to open up this article. It's an old CNN article, the most effective ways to curb climate change might surprise you. And as you scroll down, you're going to be kind of putting certain things in order. So they're going to give you like different categories, and they're going to ask you like which of these 4 things. So for example, our food, throw away less food, compost your waste, eat a plant-heavy diet, cook over clean stoves. What you need to do is figure out, well, which one do you think is the greatest, like what's the best one to do to reduce your carbon footprint? Which one would reduce carbon the most? So maybe I'm going to think it's like eating a plant-heavy diet. So you can click and drag. I think throwing away less food isn't going to be that big of a deal. Cooking on cleaner stoves maybe would be the second most effective. So anyway, you're going to rearrange it, then click how did I do, and they'll show you the actual orientation, like which one actually is first. And on the quiz, that's what you're going to be answering. So for our food, which one was the true number 1? I don't want to know which one you put first. It's once you've clicked how did I do, which one is the actual correct answer. So you'll work through those 8. And then there's a little thing at the end to reflect on. So again, I'm going to time for 10 minutes on this one to work through, and then we'll come back together to review. Let me know if you have questions or need help. 10 minutes to work on curbing climate change. Those are exactly what they sound like. Carbon sources are anything that release carbon dioxide into the atmosphere. So not surprisingly, that's emissions from cars, coal factories, cutting down and burning trees and other plant life that is contributing CO2. And sinks are anything that remove it, right? So photosynthesis by trees are taking carbon dioxide and converting it into sugar. So, if you've ever eaten an apple, you're technically eating carbon dioxide that was taken from the air and sort of recycled into a sugar, which then you breathe out again as carbon dioxide. The ocean water absorbs carbon dioxide. This is actually leading to what's called ocean acidification. If anyone's heard about this, the ocean's actually very basic. It's kind of like soap. That's why ocean water is very slippery, but it's actually becoming less basic. They call it ocean acidification because of how much carbon dioxide is being observed. So this was meant to exist in a cycle, but obviously human activity has drastically increased the number of sources while simultaneously reducing the number of sinks, right? We are cutting down trees and forests, less photosynthesis, more production of carbon dioxide, so we're offsetting that balance. Now, here's the thing though. You hear so much negative stuff about carbon dioxide, we've got to reduce carbon dioxide levels. I need to emphasize that greenhouse gases are important and are necessary for life on our planet. If we didn't have greenhouse gases, if there was no carbon dioxide or methane in the atmosphere, can anyone tell me what conditions on Earth would be like?
Would it be freezing?
Oh, yes, it would be extremely cold, right? We need these gases, very good, to trap some of the warmth, the solar radiation coming from the sun, and warm up the surface of Earth enough that water can exist in liquid form and we can live, life can exist comfortably. So we shouldn't completely eliminate carbon dioxide. We just need to reduce it down to levels that were more like they existed before humanity and the Industrial Revolution started to offset the balance. So in terms of how this works, I know I mean, I don't know if anyone's been curious, like what is it about these molecules that actually traps heat? And so different ones have different levels of impact. So you can measure this by what's called global warming potential, GWP. You can see carbon dioxide is actually very low. It's just that there's so much of it. And then fluorinated gases, anything with fluorine in it, are major contributors. Not a good thing. We'll get to that in a second. But in terms of what's going on with carbon dioxide, CO2 has the molecules actually shaped like this. It's a oxygen double bonded to a carbon, double bonded to another oxygen. And what happens is solar radiation, which I'll draw like kind of a little beam of light, can be absorbed by those bonds. The bonds are actually very springy. They spring back and forth, the oxygen and the carbon. And so it's able to absorb solar radiation energy and then release it again. And so that's essentially what's happening is that carbon dioxide sort of catching and throwing back out solar radiation energy and warming up the air that it's in. And that's the same thing that all these other things do. Methane is CH4, it's carbon with 4 hydrogens around it. And again, those bonds are capable of absorbing energy and releasing it through this sort of like springing motion. So if you're curious about that, you can look into more of the kind of the physics behind that. But essentially, just think of these molecules as being able to kind of absorb a small amount of energy and release it again. And so that's great for life on our planet because it means that all the solar radiation from the sun is being trapped in our atmosphere and is warming it up enough that water can exist in liquid form. But now that we're creating too much carbon dioxide, too much methane, and also these other kind of very unnatural fluorinated compounds, which also do this, a little too much of that solar energy is getting trapped and temperatures are rising within our atmosphere, which can actually have big impacts on life that isn't adapted to that. So again, here's the famous graph showing over time, starting from 1960 up till the present, showing CO2 concentrations in the atmosphere. This is measured in parts per million. And so obviously, can anyone tell me, are carbon concentrations going up or down? What's the trend?
Up.
Way up, right? And very gradually too, which is kind of interesting. Now, this weird kind of jiggling is just due to seasonal changes, right? In the colder months, January and April, carbon dioxide levels are actually up, and in the warmer months, and then they once things get colder around October, November, December, they go down just a little bit. But again, it's kind of just a natural fluctuation, but we're still seeing this trend upwards. So this data is actually taken from a little study center in Mauna Loa in Hawaii, but there are other places where they're monitoring it. And what if we wanted to learn back, right? What about before 1960? Have carbon dioxide concentrations done this before? And maybe this is just another part of the natural sequence. And they actually can study this. I mentioned this in our previous class, but you can actually go to the Arctic or the Antarctic and look at these giant glaciers. Does everyone see how this glacier kind of has like ribs? You can just see it in that picture there. And those are basically layers of ice that have frozen on top of each other over hundreds of thousands of years. And so what scientists will do is take a core. They'll basically dig a pole deep into the ice and then take it out like this. And so that little ice column there has little chunks that are from different time periods. They can carbon date this to figure out how long ago each of these layers of ice was frozen. And in that ice are little gas bubbles. And so they're able to analyze those to see how much CO2 is present and take an average. And that tells them then how much carbon dioxide on average was in the atmosphere 400,000 years ago. And so this is ice cores from Antarctica, which I find kind of fascinating. You can see that carbon dioxide levels have been pretty consistent up until, again, humans arrived, and then the Industrial Revolution happening right around here. And now suddenly, look at that, right? Way higher than anything they've measured up to about 1,000 years ago. They have done further studies called the Vostok ice. I'm not sure where this is from. Maybe it's the Antarctic. This is going back 400,000 years ago. So looking at almost the last million years, guessing back. But you can see, again, there's a natural fluctuation. Earth has gone through a couple ice ages and things like that. But you can see that in terms of their record, the highest ever seen was 300 parts per million. Does anyone know where we are today? We've gone up to 400 parts per million. It's 100 parts per million higher than anything that was previously recorded. And so this is a little worrying because we've never seen this on the planet before. There's going to be some ramifications from this. And so here's the key thing, and I'm going to stop here. We'll pick up on this in our next lesson. But the reason they're concerned is because here now it's contributing to the average temperature on our planet. This graph, the blue line, is showing you carbon dioxide levels in the atmosphere. The red line is showing you average global temperatures. And what I'm hoping you notice is that they line up with each other, right? As carbon dioxide concentrations go up or down, so do global average temperatures. But look at where we are now. There's the CO2 concentration. Right now, temperature seems to still be holding at the natural peak where it was. But if trends are true, that average temperature will begin to drastically increase over time. And that's why this is referred to as global warming. And there are many people who claim that this is fake, that this is just correlation, not causation. But again, that's something I'll pick up on in our next lesson. I want to stop there for now. Questions or comments on that so far? I think that ice core stuff is fascinating. It's a cool thing I didn't really know about. So, all right, homework is to make sure you've completed the classworks that we worked on today, specifically the carbon footprint analysis and the article on curbing your carbon footprint. You need to read Hewitt chapter 20.2, which is about the circulatory system. We're jumping into human biology, which I know is a little jarring, but I want to explore your direct interaction with the atmosphere, right? So breathing air is what keeps us alive, but it turns out to understand how the respiratory system works, you really need to understand how the circulatory system works. And so we're going to start with that, circulation, but know that we're building up to respiration and breathing. That's the driving theme for this. So questions on that? All right, that's all I have for you kids today. Thanks so much. Have a good rest of your day.
Thank you.